Europe that has been beneficiaries of the Innovate voucher, okay, and they will be able to receive this training regarding Industry 5.0. For the preparation of this session, in this session, we are going to have the collaboration of one of the partners of the project, that is the Institut Jules Verne, and Guy Cabinet will present the capabilities of this technology center. And later, the technology center, the Aerospace Technology Center in Andalusia, CATED, that is collaborating with CTA in a very strong, in a lot of activities, is going to present also several technologies that have available. If you want, we can start with a reminder of the project in transit, because it's the one of the two projects that we are going to have now, with an open call for finance and your ideas. That's why we have focused this presentation on this. Okay, so let's go. I'm going to change my snapshot. Can you see properly the presentation? Maria, let me know. Yes?
Yes.
Okay,
yes.
Perfect. Because I cannot see well the people. Okay. And for the people that cannot from in transit project, maybe this is the first time that they see this slide. But the objective of this project is very closely to Metastar, and the objective is to strengthen the innovation support to the innovation of the SMEs in the sector, and to contribute to the Green Deal strategy. Okay, of course we need to increase the resilience of the SMEs, and we would like to foster the cross-regional and cross-sectorial links between the industry. This project This project is focused on aerospace sector, but also in textile, in advanced manufacturing, and in construction. Those 4 sectors are the ones that we would like to strengthen the collaboration between them. This is the concept of the project. We have designed 5 steps to support SMEs in this trip. The first one is the design of the industry assessment. We have been working also in open innovation. We have an open innovation space for promoting the cross-sectoral collaboration and new business model. The third step is the customized advisory and the support that we give to the SMEs directly with funds. The fourth one is the one dedicated coaching for the beneficiaries of this project. And the final one is the resilience and some activities in order to improve the visibility of the result of your individual projects. Okay, this is the pathway that we are going to follow. We are going to support you to follow. Of course, we have had several activities of Incubate. We have had some activities of Innovate. Most of you are beneficiary of this bonus. Later, we will have a develop bonus where the SMEs will be able to apply for receipt funds from the European Commission to develop some activities, and at the end, we will make some activities to scale up your results. This is more or less the same activity, but the same schedule, but with some information of the activities. In the Incubate, we were preparing several learning expeditions. We have also travel vouchers, workshops, and webinars, and matchmaking event where the SMEs can participate. We have a bonus that is Innovate that has 2 open calls, and we have and this bonus, the beneficiary has 14 hours of coaching, and this is one of the coaching that of this bonus. Okay, in the next step, we will have the develop bonus and the Dominos vouchers, where each SME can apply for the project, and they can receive up to 49k euros per SME to develop their projects. It is allowed to have individual projects or in consortia. In consortium, the maximum amount could be 98. Okay, and at the end, we have several scale-up activities in order to improve the competitiveness and the sustainability of the result that you have had. And the Innovate has a lot of kind of support activities directly designed for the 4 sectors that we addresses: aerospace, advanced manufacturing, construction, and textile. And you could be able to be in different sessions, for example, in business model and digital transformation. All of them are inside are available inside the platform that we have. Okay, and you will be able to attend if you want. We are planning. We have also had one important activity that is the on-site activity in order to support you, in order to know new companies, new technology center in different sectors. We have designed 6 different activities. At the beginning, we have clarified workshop. We had matchmaking event at the beginning of the project. We have had 2 learning expeditions to Ljubljana to know the construction sector, and to Seville to know the aerospace sector. And now you have 2 more opportunities to join these services, okay? Because the deadline for applying for the bonus, for the voucher for traveling is open until the 7th of October, and you can go to Athens to know again the aerospace sector and advanced manufacturing, and to Barcelona to know deeply the textile one. Okay. Of course, if you are interested, you can apply directly by the website of the project. You can see there directly the calls for applications. This is only a reminding about the call timing that we have. Innovate is closed. We are now developing the implementation of the second call between September and November of this year, but we're still having a call that will open in November. And we'll finalize December or early January, and we will have the new projects accepted in February, and the winners will be able to implement them between March and June of the next year. That is only for you to have in your mind if you are thinking on preparing some proposals. This is the overall information about what we have done in this project. We are going to distribute more than 3 million euros between the SMEs in Europe of these 4 sectors through the Innovate services and through the Develop project. We expect to have at least 170 beneficiaries in between the 2 bonus, and more than 200 between the incubations, workshop, webinars, and the final event that will be here. Okay. The Innovate Core is an advisory services to support the companies to be more effective in different topics. Of course, we're going to support you in new circular business and to improve your projects. Okay. The Innovate advantage that you will receive for being part of this bonus is of course the advisor for the individual experts. You will be able to obtain the maximum, to be benefit for the maximum impact of the in transit project, because we will have a lot of visibility through Europe. Of course, you will be part of the in-transit community, where you can fund very good companies and potential collaborations in your innovations. And of course, you will have a very direct benefit. That is, if you are a beneficiary of Innovate, you will be able to obtain extra bonus in the evaluation of your future developed proposal, and you will be able to be in the top of the ranking to be financed, because we have to say that we have a lot of companies trying to receive this bonus, and there is a strong competition to win. For the second Innovate call, this is an overview of the Innovate call, only for you to know exactly the times. We will have to finalize between September, October, and beginning of November. And the develop calls is the mechanism that we have designed to provide you some funding to develop your innovations, to be able to develop new products, new prototypes, to make some market testing to facilitate the integration of your innovations in your business. As I have said, we will be able to support projects in the lump sum financing way. Okay, you have to explain properly what we are going to do, and later you will have to justify what you have done, but we are not going to request you any kind of financial justification deeply as is in other European projects. Okay, the target group for this call are the SMEs in the aerospace, construction, textile, and ASPEN manufacturing. Okay, and this is the timetable. As I have said, we expect to open in November. At mid-January, early January, we will finalize our call. The winners will be able to start to implement the project in March. Okay. And that's all from my side. This is the presentation of the project, of the projects, and I don't know. I'm going to stop to share the presentation. I have to say that we are very happy to have here our partner, Instituto Jules Verne, and Guy Cavanaugh is going to present tech development that they have, especially in Industry 5.0, that is the topic of this session. Guy, what you want?
Hello, is it okay for the presentation? I just put my...
Maybe, Guy, if you can put the full screen, it's much better.
Yes. Is it okay? Full screen?
No, perfect. Thank you.
Okay, so I am Guy Cavanaugh. I am in charge of technology transfer in Research Institute Jules Verne in France, in west of France. And this research institute is dedicated to the industry and manufacturing. And I propose in this presentation to give you a practical view of Industry 5.0 project through the presentation of concrete example. So in this presentation, I have divided this presentation into 4 parts. The first part, during 2 minutes, will be a quick, briefly description of the concept of Industry 5.0. After that, I will describe in a few minutes our institute, and the next part will be the description of real industrial project in the different field of application in the shipbuilding, in the aeronautics, in control, and in medical field, and so on. So the first part is a brief description of the concept of Industry 5.0 and Industry 4.0. So the concept of Industry 4.0 is a sort of set of technologies in order to transform industrial production. And in this Industry 4.0, we integrate different technology, for example, augmented reality, big data and analytic, and simulation, and so on. And the origin of this description of the concept is a huge company. The name is Boston Consulting Group. And after this first Industry 4.0, with the main topics around manufacturing in order to be more efficient, flexible, and so on, the concept of Industry 5.0 is an evolution in which we try to have a more holistic approach in order to integrate the collaboration between humans and machine. And we try to have a coexistence between automation and human labor, and in which we integrate in the project the different impacts, social impact, environmental impact, and economical impact too. So in this kind of industry, we'll see in these different examples, we have a global approach with human in the center of the project. And the key element around this concept of Industry 5.0 is human-machine collaboration. We will see example in robotics, customized production in order to have a more personalized way to meet the specific customer needs, environmental and sustainability in the project, and we integrate in our institute the development of human skills in the project in order to enhance the skills and know-how of the different people involved in the project. So the next parts of my presentation, during 4 minutes, will be a description of our institute in the field of Industry 5.0. So the main activity of our institute is Industrial and Collaborative Research Center dedicated to manufacturing in aerospace, shipbuilding, energy, and so on. We propose different projects, European and French collaborative projects. We propose different research services, and we propose transfer of technology in terms of sales of patents and a project in order to transfer the results of the project. The main mission of this kind of research center in France is to accelerate innovation and promote technology transfer to the factories. And we are in a network. The name of this network is the French Institutes of Technology in French, in which there are Research Institute and Energy Transition Institute. And the core of business of these different institute is the collaborative research. The strategic positioning of this kind of research institute is this approach in which we propose projects with solutions oriented. We try to have synergy between manufacturer and industrial integrators, and we propose a cross-fertilization between different sectors. For example, between aeronautics and shipbuilding, between energy and car manufacturing, and so on. And we are around 150 people in our institute now, with industrial competencies, with industrial platform, and with the capabilities of project management too. So you can see the different figures of our institute. The average of activity is around 25-30 million euros of activities per year, and the perspective is around 40 million. You can see the different partnerships in our institute in different fields of activity. You can see the slides in after my presentation. And in the field of Industry 5.0, we propose different R&D thematics around flexibility in manufacturing, in the process, in the field of assembly and joining of large parts, and in digital manufacturing. And for each different thematics, we address real challenges in industry in order to enhance the quality, the performance of product in industry. And the three main R&D activity are integrated product and process design, innovative manufacturing processes, and flexible system. So you can see the different teams, and each teams is associated with equipment in a real platform. You can see here the composite equipment. I just put my laser, and you can see here robots in the welding application. We will see an example, mobile robots, and simulation and modelization. So the global process in this kind of institute is a process from industrial needs to the factories. And during this technology maturation period, we work on an industrial research project with involvement of industrial integrators. We use real cases you will see in the example in industry, and we have technical economic assessment studies in order to facilitate the transfer of the results in the factory. And in our institute, we have a lot of links with cluster in France. You can see, for example, EMC2 or other company, other cluster. And we are involved in different European projects, in different field of application. For example, in robotics, in transit project, and in the field of the process in building of a plane, and other project in repair, for example, activity in the composite. So after this first view in 9 minutes of our activity and the concept of Industry 5.0, I will present during 10 minutes 8 different research projects, concrete research projects in the field of Industry 5.0. The first project is a project ASPEN, this is the name, is a project in the welding with the mobile robots. You can see the mobile robots just here. And we propose this solution in partnership with end users. The first end users is Chantier de l'Atlantique. It's a French shipbuilding. And another is the field of submarine, nuclear submarine production. And in this project, the aim of this project is to develop components of robotics, and another part is the control and command of these robots. And this robot is not a real robot. It's a cobot in interaction with human. And in this project, as you can see here, the main part of the project is human-machine collaboration. And the aim in terms of impact of this project is the control, the weight of the robots in order to have the good mobility. After that, we try to optimize the cycle of production of ship, and we try to optimize the quality of the welding. So you can see here the building of a ship in order to help people to build the ship with robots. You see here, very important point in this activity of Industry 5.0, this is the involvement of SMEs, small and medium enterprise, and Europe Technology is a company with 400 people in west of France, and this company is involved as a supplier in order to produce the solution to the end user. You can see just here the welding robots working in coactivity with worker. They are a real coactivity with the worker, and we need to supervise this activity, and we used an IT model with digital tools associated with the welding robots. This is the first example, and here there is the link to the video of the presentation of this project, and the different activity of end user, researcher of your institute in this project. The second example is an example in the field of handling and positioning of heavy parts for assembly in aeronautics. The name of this project is API project. And in this project, in terms of specification of Industry 5.0, we propose a customized and flexible solution for the production of airplane. And in this project, we are working on the development of a system of robots in order to enhance the quality of assembly of different parts of plane. And the system consists of positioner, robots positioner, you can see just here, okay, mounted on automated guided vehicle. And this system is controlled and in closed loop with a visual system in order to control the global system. The industrial impact of this project, the main is the flexible solution and the reduction of the cost with the reduction of the line surface, the line production surface, and we try to enhance the reconfiguration of the workflow in Airbus company. So in this project, there are different partners, Airbus company and Airbus Production Atlantic, company in the field of automatic activity, and different company in research activity in visual survey. So you can see the aim of this project in order to help people to build a plane with robotics. You can see the complete parallel robots with the mobile robots in order to facilitate the assembly of the different parts of the plane. And you can see here the digital parts of the project, because in Industry 5.0, there are a lot of activities in the field of control and IT supervision. And you can see the simulation here. This is the simulation. And here you can see the real world of assembly between two parts of airplane in Atlantic, in Airbus Atlantic production line. The next two examples are examples in Industry 5.0, in which we have a global approach of production and in the same time control. And in this kind of project, we try to overcome the lack of flexibility of the different robot parts. You can see here the robots with arm and mobile robots, the different sensors with different technologies, and the target. This is the parts of the system. The second part is the parts in the control. And after that, we use measurement system and supervision. And in this kind of product, we integrate automated control of the quality of material. We can propose visual inspection or geometric inspection. And during the production, we propose an analyzing of the different parameters in order to optimize the production. So this part is the control of the project, and in the same time we have a project with the main topics that this one. And in this project, we try to control in composite infusion in the naval activity. We try to optimize the production, the cost of production, and the very important point in terms of human impact is that in this project, we propose an interface in order to reduce the mental workload with tools of decision support. Okay, So this project is not only a project in the technical field of process optimization in composite, but we integrate another part in the field of human optimization activity in the production. And we propose for this different project, different monitoring, for example, for the infusion, we propose different sensors, and you can see here the system with a laser measurement, another system of measurement, and we try to propose interface in order to facilitate the work of operator in these two projects. So after this 4 projects, I propose a more open view of 5.5.0, for example, in the field of healthcare, because there is industry 5.0, but you can have healthcare 5.0. And in this project, our institute was involved in order to enhance the quality of system, a global system produced by American company is G Healthcare in USA. And in this project, you can see a mobile robot in surgery room. You see the X-ray system here and the surgeon and the patient. And in this project, we work on the improvement of this cobot, because this is a cobot in interaction with patient and surgeon with interface. And in this project, the very important point is that we work with the different teams in process, in composite, in the field of robotics, with different solutions proposed to enhance the quality of the robots, and in simulation and modeling, as you can see here, to propose a more efficient solution. And in this project, we involve end user, surgeon, not patient, but surgeon, and we have a global view, a holistic view of the project in order to find the good equilibrium, the good balance between technical parts, economic part, and human parts. So this project is project in the field of healthcare 5.0. The next project is a project in the nuclear application. This is a sort of industry application. And in this project, we integrate environmental impact in order to repair the parts in a nuclear application system. And in this kind of project, we integrate different technology. For example, you can see an hybrid technology with a welding technology here with the robotics welding, and in this part with 3D welding, and we use different solution of robots, and we integrate modeling and optimization with IT solution in this activity of repair with the company Framatome in France. The next project is a project in cobotics, in logistics 5.0, and in this project of logistic, we try to propose a solution in which we integrate some knowledge in supervision, some simulation of people in interaction with machine, and we worked with these partners in the field of architecture of the system. The last example is an example in the field of cable robots for manual and automatic painting. And in this project, with an integrator, the name of the company is SNEF and Clit System, we integrate robots in area in which they are operator with a manual solution of painting, and we integrate a solution, a mobile solution, with the robots with a cable, parallel cable. And in this project, we work on human interaction, simulation, and after that, we propose a solution with this kind of cable robots for this kind of application of painting in aeronautics activity. So to conclude, in this presentation, I presented industrial and R&D projects in advanced technology, metal and composite manufacturing, IT supervision in different fields of application, aeronautics, shipbuilding, naval, logistics, energy, and so on. And I tried to show a global and human approach of Industry 5.0 with interaction between people and machine, for example, with the welding robots in logistics, in surgery, in which I describe flexibility of production in assembly activity, in painting with parallel robots, and in which I describe improvement of technologies with an economical analysis, for example, in nuclear and production application. And the last point in this presentation is the fact that there are a lot of small and medium enterprise involved in this project in order to propose technology in robotics, for example, with Euro technology, and to integrate end user and industrial seat with this technology. And in our institute, we develop a new solution in partnership with group with the involvement of these SMEs to produce a solution and to propose solution to the market. So this is the end of my presentation on Industry 5.0. And if you want more information, there are a lot of links in my presentation, and you can have this different description in the video, and after that can have an exchange during the coaching in transit project on this topic of Industry 5.0. Thank you very much for your attention.
Thank you very much, Guy. I think that we have received one question in the chat, and that's one question for you that said that what are the Industry 5.0 principles? I don't know if you would like to answer, or we can wait later.
I don't see the question. Okay. Good enough. So I described the different principle on this different example. The main principle is the first point is that there are a set of new technology in simulation, in robotics, in cloud, in additive manufacturing. The second principle is the fact that we have a holistic approach in the project in which we integrate different dimensions, for example, technical dimension, economical dimension, human dimension, with a holistic approach. And perhaps the third principle could be the integration of human in the center of the project in order to propose the good solution in interaction with people. Is it clear?
I think so. I hope so. Okay, so thank you very much, Guy, for your great explanation. And now it's the turn of Javier Garrido, who's in the avionics and support system of the CATEC, the Aerospace Technology Center in Andalusia. Javier, you're really welcome. The floor is yours.
Thank you, Silvia, for the introduction and also for the invitation of us to this webinar. I think that you can see already my presentation. Is it?
Yes.
Okay, perfect. So just a brief introduction of the Center of Aerospace Technologies here in Andalusia. We are, as I said, based in Sevilla, where our headquarters are. We are more than 125 people working in the center. We also have some offices in the north of Spain, in Santiago de Compostela, and we also have 2 flight centers in the east part of Andalusia, in Jaén. We are divided in 3 technological departments: the Avionics and Systems department, the one to which I belong, the Smart Industry department, and finally a new one that is already open just 1 month ago. It is the Energy department. Regarding avionics and system, the department, my department, what do? We work since with all the avionics and systems regarding aeronautics that you can imagine. So we fly and we design and develop aircrafts in US drones and airpass, and to the space, and through innovative innovative aerial mobility, and also aviation autonomy, and also with the high altitude pseudo satellite aircraft, these aircraft that are expected to fly in the stratospheres, and they are in the middle way of an aircraft and a satellite. Then regarding the smart industry, it is not my unit, but just to present the department, they have 3 different units: the artificial intelligence and robotics unit, additive manufacturing, and testing and advanced processes unit. And finally, the new energy department, as I said, that we have already opened, will be focusing hybrid energy platforms with hydrogen batteries and unit of control together with advanced semiconductors, and optimal power supply through artificial intelligence, and advanced testing of power supply units. Okay, what are my intentions with this presentation? I want to present to you, as my colleague did before, 3 different projects regarding avionics and system units, so UAVs, drones, how we apply these drones to the construction, inspection, and maintenance sector. So the first project is Omicron, the one that you can see now in this slide, which is a technology-focused project that combines the most modern automatized tools in a way that can be adapted and applied to a specific local requirement. And with these technologies and with this combination of them, we want to develop and create an intelligent road-assessed management platform. The expected impact of this project were, because it is already finished, the final demo were just 2 weeks ago, is to increase of safety in road intervention actions for road user and personnel, to have a more efficient road intervention processes and reduction of traffic disruptions, and overall reduction of maintenance costs, and also increase the road network capacity. So what did we do in this project? As I said, we are our core work is in UAVs, avionics and systems. So we did a platform, a long-range inspection of roads, and we did a reconstruction of photogrammetry-based 3D maps of the roads in order to detect all the assets that have the road around, and also to try to detect defects and to increase the efficiency of the inspection of the road. We did all of that with an onboard vision-based threat detection system. And here in the video, you can see a first validation scenario that we did in our facilities here in Sevilla. The final validation was in our test center in Jaén, in one of them, in Atlas Bravo. We flew a distance of 1,200 meters with an altitude of 35 meters and a lateral separation with the runway of 40 meters. We flew the aircraft with a speed of 7 meters per second, and the photogrammetry images were taken every 6 meters. With that, here you can see the result of the reconstruction of the road, of the runway, and you can see the detail that we could have with these parameters and with this onboard system, that vision system that we developed for the project. You can see here the detail that we can have, and we were able to even to detect some defects on the road with that. The next project that I'm going to present is Beyonders. Beyonders project aims to improve efficiency, safety, and quality in the construction sector while reducing the environmental impact of building sites. So what are the project contributions to that objectives? We are trying to have a successful integration of the next pioneering technologies, and regarding CATEC, this pioneer technology will be the autonomous vehicle and the human-robot collaboration. We are going to demonstrate the impact of the use of these new technologies on the efficiency for resources and also with the reduction of waste and embodied CO2 emissions. And finally, the demonstration of the safety of the new technology in a construction environment. In that sense, we are adapting our LiDAR inertial odometry localization for a tunnel use case. So here in the video, you can see how we have tested already our UAV flying into an indoor facility, a tunnel. We have developed a free GNSS localization system based on visual and inertial capabilities, and fusing all this data, we are able to locate our UAV into the tunnel, and we are able to inspect with visual cameras all the assets. Here is a real fly, you can see, and in the next slide I'm going to show you how we do a simulation improving not only the localization but also the path planning and all the trajectory improvement to navigate through the tunnel in the best way. So here you can see how we have developed an autonomous exploration algorithm based on graph-based algorithms, and here you can see how the UAV is exploring all the unknown environment and reconstructing all the tunnel and all the assets to be able to afterwards came back and analyze all the possible defects that we have. So that is all regarding Beyonders. Finally, one of our more proud projects, I could say, the one that I want to present in depth is piloting. Piloting project has been a 4 years project coordinated by us, by CATEC. It has been a project, an Horizon Europe project, and you can see all the partners that we had involved in the project. Here in piloting, we had 3 different use cases. It was a focus on the inspection and maintenance sector, and we wanted to inspect and to maintain refineries, viaducts, and tunnels. In CATEC, we developed technologies for the use cases of refineries and viaducts, as you will see. For refineries, we did NDT, inspection and maintenance procedures, and with the viaduct, we developed a visual inspection UAV. Apart from that, another added value of CATEC, part of the coordination of the project, was the development of a general robot control station, because piloting was not only based on UAVs, but also with UGVs, so ground vehicles. So we developed a ground control station in which an operator could control all type of vehicles, not only UAVs, but also UGVs. So, okay. The first one, the first robot, the first UAV that I'm going to show you is the Aerocam. As I said, it is for visual inspections. This UAV is an automated visual infrastructure inspection system. It navigates with a robust GNSS-free localization system. As you can imagine, below a viaduct, we lost all the GNSS signals, so we have to refer all the system with a global referencing system to a permanent 3D map. So before of flying to the viaduct, we had to take all the 3D map of the viaduct, and then with the robust GNSS-free localization system, we were able to locate the UAV all over the viaducts. We have also developed a robust control with our autopilot and with an active obstacle detection to increase the robustness and the safety of the operation. Here you can see the Aerocam flying. It was a fully autonomous inspection, as I said, with a high-precision GNSS-free navigation system. And during all the flight, the active obstacle detection system was activated. And with all the combination of this, we were able to repeat all the inspection through all over a year. So here in the video, you can see the operation of the aerocam, but in the right-hand side, in below, you can see 4 different inspection of 4 different points of the viaducts and in 4 different days of the years. And you can see how the shadows and the sun, the light is changing, but the UAV is able to came back to the same location and to inspect the same assets during a year. Here you can see also the localization system, how it works with a LiDAR. So the UAV is flying and matching its position with the 3D map that it is already taken for the viaduct. The next UAV that we developed in piloting was the hybrid. The hybrid was devoted for the inspection of non-insulated pipes. The inspection on the pipe was performed by a crawler. So the crawler was on board the UAV. The UAV went to the pipe, it landed, and it deployed the crawler to make the inspection. The detection of the pipeline was fully autonomous, and it was also developed with the CATED autopilot. Here you can see the aerocam, the hybrid in operation. In the left-hand side, a video of the real operation. In the right-hand side, a video of the localization system based on a fusion data fusion system where we fused the vision cameras, total station map, and 2 LiDARs, one 2D and one 3D. With that, we were able to look. You can see now in purple how we were able to detect the pipe, so the operator can select in which pipe we want to land. And here you can see how the robot is autonomously landing on the pipe, and then it will deploy the crawler and make all the inspection. Then the UAV, as you can see now, will take off from the pipe again autonomously and will land in the takeoff and landing spot. Also, it was a GNSS-free navigation system. And finally, one of the, I can say, most proud development that we have done in CATEC is the Aerox. It is devoted to NDT inspections. As you can see, it is a robot in which we have an effector in which we put and we integrate the sensor, UT sensor, PET, eddy current, whatever sensor that we need for the inspection, and we are able to touch the surface of the asset. It doesn't care if it is flat or a curved surface, and we are able to perform the inspection and take all the measurements. Here you can see the evolution of the concept since the very beginning with the first version until the last one that we have developed in piloting, and it is a more robust, not only in the frame and in the hardware, but also in the avionics, control, autopilot, and all the sensoring that it is integrated in the aircraft. Here you can see the Aerox in a real environment. In the left-hand side, the third version, the testing of the third version in our facility, and in the big video that I am showing is the second version of it in a real refinery spot in the north of France. I can say also that all the operation is fully autonomous. The pilot is there only for safety and because of regulation, but all the operation is fully autonomous. And once the Aerox touch the surface, the operator on ground can pilot the crawler, the N effector, and navigate through the surface and take the measurements that are needed for the inspection. And finally, as I said, we also designed a general robot control station. Here is just an example. I wanted to put the aerocam because you just saw it in operation. So We develop a friendly human interface to control and all the robots, and also to plan all the inspections with inspection points or if the data that it is needed to capture. It was a really nice work, and I can say that it is an open source, that it is available for everybody. And if anyone has interest on this tool, just let me know and I can send you the reference in which you can download everything. And finally, it is not a project but a technology that we are currently developing, that it is the swarming and teaming technologies that we have already deployed for some detection projects and surveillance. But now we are starting to make this development available for the construction sector. So we are starting to study how to apply this swarming technology to make visual and entity inspection both and everything at the same times. With that, we can increase the efficiency of the operation because we will need only one single operator to operate all the swarming, as you can see here in the video that we have already did in the past for surveillance use cases, but now we are starting to think and to develop that for visual and entity inspections. So that was all for my side. Here you have my contact. That's all. Thank you for your attention. I'm open to answer any kind of question. Thank you very much.
Okay, Javier, Javier, thank you very much for your presentation. Very interested. You have to say that one of the developments that you have presented was the Innovation Prize, rather, of the European Commission.
That is true. That is true. The Aerox was.
The Aerox was the first version. And to finalize this presentation, I need to present you some snapshot about the MetaStar project that is also corroborating in this presentation, only to show you some of the results that could be useful for the SMEs in order to, in the future. Okay, I'm going to take only 5 minutes to make this presentation, and at the end, maybe some questions that we have here can be presented to the audience. Okay, I'm going to share with you the presentation, okay, of the Industry 5.0 regarding MetaStar, and it's only a snapshot very quickly to let you know the result that we have had and what we have done it. Okay, we have been in supporting the MetaStar project. Was objective was to deploy new processes and technology of the sector to be more resilient, to strengthen the aerospace and defense system, and to provide also skills to the aerospace and defense key players in Europe. Due to this fact, we have made some different trainings that has been performed that has been done it with the different European cluster that we have had in Europe. Okay, so taking into account different soft skills, and we had a very high level of resource, and this training has been disseminated. I don't know if they are published, but if any company is interested in it, they can also ask us, and we will show them some snapshot of them. We have also prepared very interesting map in Power BI where you can detect the key actor in the European level regarding important stakeholders to be digital innovation hub and different stakeholders that can support the aerospace sector. You can check it and try to know who can support you in your regions. Okay, it's another interesting result that we have obtained in MetaStar. And one important issue that we have had is the direct support to the companies. Okay, we have had 35 number of application of project. We were able to finance at the end. I think that I don't 35. I think at the end. Sorry, I didn't put the global figures, but we gave them 2 million euros. Okay, that were requested, and we were supporting them through all of Europe. You can see here the statistic of the different countries in Europe that have received the funds. And of course, those are the name of the project that has been financed. Okay, 6 and 5. in each technology. And maybe you can, some of this technology could be interested for you to collaborate. And I wanted to disseminate this and the number of the project, just in case you would be able to collaborate with any of the participants. And that's all from my side. And now is the turn of the questions. I don't know if there were a lot of questions from the assistants. We have only 2 or 3 minutes. Javier, Guy, there is a question that is quite interested. One of the speakers asked, what is the difference? What makes different our projects from Industry 5.0 from the Industry 4.0? Maybe Javier, Guy? Can you open your cameras? Guy? Oh, okay, that's okay. Who would like to answer? I have a clear answer for this, but if you want. Possible? Javier?
Yes. Sorry, I don't know if was Guy first or me. It is a very interesting question, and really, since Industry 5.0 is not my expertise and I'm not involved in that, it seems difficult to answer for me, really. So if you have a good answer, Silvia, you can go for that.
No. I was collaborating very deeply with CATEC and the approach of having the human in the centric of the development is the approach. In fact, I know that CATEC has this approach since the beginnings, not since it was Industry 4.0, because in fact all the development that you have presented was well designed in order to avoid the risk of the human in the different application and performance they have to do in the industry. Guy, I do not know if you want to answer also.
This is the question about the integration of industry founder. This is the question about this topic.
This is the second one that we have. The first one was related. What is the difference between Industry 5.0 and 4 in your projects?
Okay, I presented different example of project in which they are human in the center of the project in my presentation, and perhaps in this topic on Industry 5.0, there is a dimension of communication, and we have a lot of projects in industry and in research in industry, but the difficult point is the reference with the definition of Industry 5.0.
Okay, Guy. Thank you very much for that. There is another question that is in the chat. Okay, because for the second, I do not know exactly what I wanted. Why?
Hello,
Michael Rada.
I don't know if Michael can talk because it's not allowed. Okay.
Yes, I can. So sorry to disturb. I just would like to specify. My name is Michael Rada. I'm the founder of Industry 5.0. And I'm sorry I was not able to join the entire time. Industry 5.0 was started on December 1st, 2015. And the question about the definition, it is not the fifth industrial revolution, but it is the first industrial evolution. And this is why I ask about the human centricity, because in the projects which you show up and presented, which are very interesting, the humans generally are not there. They are not human-centric. They are away because one part was that everything is autonomous. The second part is, the question is, what the people will do. You know, Industry 5.0 was established to build wasteless world for all. And this means for every one of us, there will be a work, which I like technology. I like AI. No, nothing against, but it must be a tool. And I have seen all of your presentation, sorry not to be for the whole presentation, because I was in a factory, but it is important to understand that there must be place for human application, for us to be there. And this is very important. And the basic part is we prevent waste to happen, all types of waste, and there are 5 of those. But I do not want to disturb, just would like to specify that the definition of Industry 5.0 is a very simple, and even the European Commission referred to my definition, which is quite long, but it is the first industrial evolution ever led by man, by human. And second part of the answer is, it is the missing link between nature and human-made ecosystems. And this is important to have on mind. And I will be happy to work with all of you. I'm in Czech Republic, but the link to my profile and so on is there. So I do not want to disturb anymore, but thank you for the presentation, and I hope we see each other soon again.
Thank you very much, Michael. It's a nice approach. Maybe because most of us are always working with a lot of people, maybe we didn't see your specific approach. But of course, the human is in the base of all of this, because all of this kind of technology, you need more human to control and to be able to perform all of these applications. But I don't know if you, Guy or Javier, would like to answer.
Yes. In an example that I presented just in the field of composite monitoring, human is in the center of the process in order to check infusion of matrix in composite, and we develop system to help people, to help operator in order to reduce the mental workload, And now in the project in our institute, there are industrial project with machine, robots in interaction, and other solution in order to help people with interface, in order to help to reduce the workload when operator work on very expensive parts, for example, parts for submarine or very costly parts. And in this kind of project, technological project, the technology is a technology to help people to reduce the workload. But in order, you underline that there are a lot of projects in which there is interaction with people, but no people in the center of the project. There is some project like this.
Okay, thank you, Maria. I think that the time is, I have seen you, the time is over, so please.
Thank you very much to all of you. Thank you, Silvia. Thank you, Guy. Thank you, Javier, for the amazing presentation. And of course, thank you very much to all the participants in this webinar from the part of In Transit, Innovate. And of course, thank you very much to MetaStars. But I'm really sorry, we are out of time and it's time to end the presentation. Thank you very much to all of you, and we hope to see you again in the next webinar and events. So have a nice day and see you next time. Thank you very much.
Thank you very much.
Bye.
Thank you. Bye.
Thank you very much. Bye.
Thank you. Bye.
Thank you very much.
Thank you. Bye.
Thank you. Bye-bye.
Thank you. Bye-bye.